Hey everyone, welcome back to your learning journey in the statistics and probability for data science. Now, this video is all about understanding the measures of position. So, as we proceed in this video, we will learn about the measures of position, the key concepts under this measure of position, that is percentile, quartile, standard scores, and then we'll take up an example data and we will see how to compute these measures of position. Now, I want to take this moment and I want to thank you for each and everyone for all the wonderful reviews that have got on our Udemy course, that is Statistics and Probability for Data Science, which is a project-based approach on learning the statistics and probability. So these are some of the reviews that we have received on our review page. It mentions that great explanation of statistics, loved the way you connected with the ML topics in between, which kept me engaged. And thank you so much, Samyukta. And Mariano has mentioned that the concepts are clearly explained, the use cases are very helpful. Python coding is explained clearly, so beginner to intermediate programmers can fully understand the algorithm. Thank you so much, Mariano. In case if you haven't joined and if you are interested to join the premium community, go ahead and check out the link in description and I'll ensure that you'll get the best price in Udemy. You can also join from our website as well. Okay, so proceeding along and in our learning journey of this video, so let's get started with measures of position. Now, when I say measures of position, a measures of position helps us to determine the position of a single value in relation to the other values that I've got in a sample or a population in my data set. So basically, it tells me as where a certain point would lie or where it would actually exist in my data set. It just tells me where exactly that I'll be. You can think of it as your class attendance or your class ranking. So when I say rank, it will just tell you as where exactly do you stand in terms of ranking, in terms of the score. So that's what a measures of position is all about at a very high level. It tells us where exactly that we stand. In this scenario of statistics, it is a where exactly my data stands. Now, in order to express this where exactly this data would stand, we basically use three measures of position. Let's start with percentile. Now, in the scenario of percentile, we assume that the elements in my data set are the rank ordered from smallest to largest. Now, once I have got this order data, the next thing that I'm going to do is I'm going to divide this ranked order set of elements into 100 equal parts and I'm going to call it as a percentile. Now, if I want to help you connect back to our other concepts, I can clearly say that if the value that I find at the 50th percentile, so that 50th percentile value will be my median value. And if I have a value at 50th percentile, what it indicates is that that particular value is greater than 50% of the observations in the data set. That is what a simple percentile would mean. So, key thing that you have to remember, I'll be finding this percentile only on the ranked order set. This is very important. Once I have ordered the data, then only I'll be calculating the values of the percentile. Now, apart from percentile, we'll also use the quartile, which is a common methodology that we use it to describe where exactly my data would lie. And this is one of the common measures of position which we generally use it to find the outliers in my data set, especially when we construct the box and whiskers plot. And you learn about it as we progress in our learning journey in the next section. For now, if I want to describe this quartile, so quartile, it will help me to divide my data set into 4 equal parts. Here, we will find 3 important statistic value, that is Q1, Q2 and Q3. That is quartile 1, that is first quartile, second quartile and third quartile. So first quartile is also called as lower quartile. The second quartile is called as median and the third quartile is also called as a upper quartile. The way that we divide this data set into quartile is for my given data. First, I'm going to compute the median. Then, as a result of finding this median, I will have the data into 2 parts, one on the left hand side and the other one on the right hand side. Now on the left hand side of the data, I'll again compute the median, and that median value, I'll call it as a lower quartile value 1. So as a result of this has divided the left part of my data into 2 parts. Similarly, I'll take up the right part of my data set and I'll find its median. In this example, that is 9, and I'll call it as Q3, that is my upper quartile. So as a result of this, I'll also divide this right side part of my data into two parts. So in total, I have divided my data set into 4 equal parts, and that's the rule of my quartile. The common thing that we generally use is we'll also find the interquartile range, which is given by Q3 minus Q1. Clear? Great. Now moving on, the next measures of position that we have got is standard score. Now this is one of the very important measures of position. So this will describe how many standard deviations an element is from my given mean. So I can say if the value of z score is less than 0, okay, if the value of z score of a particular element is less than 0, then that particular element's value is less than the mean. Now for a particular element, if I find the value of z score is greater than 0, then that particular mean, okay, that particular mean is actually less than the value. That means my value is greater than the mean. To give you an example, if I have an element, okay, x, if its z score is minus 1.5, it would mean that this is less than mean. This particular value x will be less than its mean. That is mean of my entire data. And if I have a value of x where its z score is given by 0.2, which is a plus, then it would mean that this value of x is greater than the mean of my data set. Now when I find a data where its z value is actually equal to 0, then in such scenarios, okay, it would mean that my value of x is equal to mean of my data set. And this is a formula for finding the z score, and keep a note over here, team. So whenever we are computing the standard score using the sklearn.preprocessing, we generally convert my given data into its respective value of z. So what will be the property when we apply the standard scaler? Yes, we will have the mean as 0 and standard deviation as 1. So important property that you need to remember is once I convert my entire data set into its z-score, I'll have the mean as 0 and standard deviation as 1. So this is one of the very commonly asked interview question, especially when you're applying as a fresher. So key thing to note over here is, I'll repeat as this is very important, when I apply standard scaler or when I get the standard score for the given data set, it will convert my specific column such that I'll have a mean as 0 and standard deviation as 1. Okay, now that you have understood the key concepts in measure of position, that is percentile, quartile and standard score, let's take up an example data. Let's calculate it on an Excel sheet so that you can visualize those values. I'll open up an Excel sheet over here with me. I'll start by getting an example data. Let's say I'll have my data set like this. I'll say 10, 15, 16, 20, 22, 39, let's say 27, I'll say 15, I'll say 18 and so on. Let's say these are all the data that I've got in my data set. Now let's start by the first thing, that is the measures of position. In the first scenario, let's start by calculating the percentile. Now if I want to calculate a percentile in Excel, okay, I can directly make use of a function that is called as percentile function. And here we can just specify the range, and we have to specify the percentile, that is the percentage. Let's suppose if I say it as 50% and I'll press the enter key. See, I've got the value. I've got the value over here which describes the 50 percentile on my given data. Okay, so if I want to get the value of 10th percentile, okay, I'll give you one more example. If I want to calculate the value at this 10th percentile, then I can just mention my data set and specify as 10 percentile. Alternatively, you can also mention it as 0.1. This will give me the value at 10th percentile, that 10th percentile. So this is how we calculate the value of percentile. Now, when we talk about the other value that I have seen right now, especially when it comes to measures of position, is my quartile. If I want to find the quartile from my given data set, then in that scenario, we can get the quartile using the quartile function. I'll say quartile, that's the function name. We'll specify the array. Okay, once you specify the array, we will have to specify the quartile. So here it says 1 is the first quartile, 2 is the median value, that is a 50th percentile, 3 is the third quartile, and 4 is the maximum value. So I'll say 2 and I'll press the enter key. Now if you look into this scenario, this is my Q2. Okay, this is actually my Q2, and this Q2 is equivalent to 50 percentile, that is the 50th percentile. See, that's what we clearly observe in this given data. Okay, and another thing, if I want to find the value of Q1, I'll get the value. Okay, I can apply this quartile function, specify my data, and this time I'll mention as 1. So this will give me the value of Q1. And if I want to find the value of Q3, I'll call the quartile function again, specify my data, and this time I'll mention as 3. This will give me the value of Q3. Now if I want to get the IQR, which is nothing but my interquartile range, this is actually the difference between Q3 and Q1. In this scenario, the IQR is given by 7.5. Okay, so this is about how to find the quartile for a given data. Now lastly, we have talked about the Z-score. So what is Z-score? Z-score is nothing but for each and every data. So we'll take the difference from the mean and we'll divide by standard deviation. So let's note down the mean. I'll say mean. So mean is nothing but the average of my data set. So this will be the mean of this data set. And standard deviation is given by, I'll say standard deviation for this given data. Okay, so this is the value of standard deviation. Now in order to calculate the Z-score, I'll take my data, I'll take the difference from its mean, okay, and then I'm going to divide it by the standard deviation. So I'll divide it by my standard deviation. So this is the value of my Z-score. And if I do the same thing for each and every row, see, this is the respective values of my data set. Now during the learning, I have mentioned that if the value of Z-score, if it is less than 0, it would mean that the value is less than average or less than mean. Let's validate it. In this given data, the value of mean is 20.875. So wherever the values which is less than 20.875 in my data set, so I'll just highlight it over here. See all these 4 values less than 20.875, hence you see its respective Z-score is less than 0. And wherever the value which is greater than 20.875, so those respective Z-scores is greater than 0. So this is how we interpret the value of Z-score. So as part of your learning journey in this video, you have intuitively understood what are the measures of position that we have got. So you have learned about the concept of percentile, quartiles. Along with that, you have also seen the importance of Z-score. Now, as we progress in our next learning journey, we'll see how to do all these things with the help of Python programming language, because as a data scientist, we are interested in coding everything in the programming language so that we will be comfortable in applying the data set whenever we are doing the data analysis. So thank you so much guys for watching till the end, and I'm so excited to see you on the next session. So take care.